There is a powerful and deeply ingrained myth that governs our modern approach to learning and skill acquisition. It is the myth of the grind. It is the seductive but brutal belief that the path to mastery is paved with sheer, brute force effort applied in long, unbroken stretches of grueling work. It is the voice that tells you that to learn a new language, you must immerse yourself for 8 hours straight, that to master a musical instrument, you must practice until your fingers bleed, that to absorb a complex subject, you must lock yourself away for an all-night cramming session, relentlessly hammering the information into your brain until it submits. We glorify the student who never leaves the library. We celebrate the 16-hour workday of the entrepreneur. We worship at the altar of the hustle. This philosophy is a ghost, an artifact of an industrial age model of productivity, where time on task was directly and linearly proportional to output. More hours at the factory meant more widgets produced. But the mind is not a factory. A knowledge is not a widget. The mind is a garden. And in a garden, the principles of growth are entirely different. You cannot force a seed to sprout faster by drowning it with a week's worth of water in a single afternoon, or by blasting it with concentrated sunlight for 24 hours straight. Such an approach does not produce growth. It produces death. Growth in the natural world requires not just nutrients, but a rhythm. It requires periods of rest, of quiet, of unseen and incredible activity happening deep beneath the surface, in the dark. What if I told you that the most critical and productive moment in your learning journey are not when you are staring intently at a book, but precisely in the hours and days after you have walked away from it? What if the secret to building durable, long-term memory was not to study harder, but to study smarter, by consciously and strategically introducing periods of intentional forgetting? Imagine having the ability to program your mind to learn while you sleep, to forge new skills with less perceived effort, not more. This is not a mystical fantasy. It is a fundamental, immutable law of neuroscience, a powerful cognitive technology known as the spacing effect. Today, we will dismantle the destructive myth of the grind, and in its place, we will install a new operating system for effortless, elegant, and lifelong learning. The spacing effect is one of the oldest, most robust, and most consistently replicated findings in the entire field of experimental psychology. It was first systematically identified by the pioneering German psychologist Hermann Ebbinghaus in the 1880s during his groundbreaking, self-administered studies on memory. In its simplest form, the principle is this: we learn and remember information far more effectively and for far longer when we space our study sessions out over a period of time, rather than cramming them all together in a single, massive block. A student who studies a subject for 1 hour a day for 10 days will have a vastly superior long-term retention of that material, weeks, months, and even years later, than a student who crams for 10 consecutive hours the night before an exam, even if the total time spent studying is identical. This seems profoundly counterintuitive. Why would less concentrated effort lead to a more powerful and lasting result? The answer lies not in our conscious minds, but in the deep, ancient, biological processes of memory formation itself. Learning is not a singular event that happens when you read a page. It is a two-part process. The first part is encoding, the conscious act of taking in new information through your senses and making initial sense of it. This is what happens in the classroom or the library. The second, and far more critical part, is consolidation. This is the complex and energy-intensive neurological process where the brain transfers fragile, vulnerable, short-term memories from the hippocampus into the stable, long-term storage of the neocortex. This process is happening largely unconsciously, most powerfully while we sleep. It is the brain's diligent nightly gardener, tending to the seeds of information you planted during the day, pruning away the unimportant, and strengthening the connections for what truly matters. When you cram, you are perpetrating a massive denial of service attack on this gardener. You are throwing 100 different seeds into a single hole and dumping a month's worth of water and fertilizer on them all at once. The system gets completely overloaded. The brain, unable to differentiate the signal from the noise, treats most of the information as low priority, transient data. Because it does not see the information repeated over time, it assumes it is trivial and does not invest the significant biological energy required to build and myelinate permanent neural structures for it. Cramming works for passing a test tomorrow, but it is the neurological equivalent of writing in sand. The information is washed away by the next tide. The spacing effect, by contrast, works because it sends a clear and powerful signal to this unconscious gardener. When you encounter a piece of information and then walk away from it for a day, you naturally begin to forget it. The memory trace, the specific pattern of synaptic connections, starts to fade. Then, when you re-encounter that same information 24 hours later, you are forcing your brain to engage in what memory researchers Robert and Elizabeth Bioch call a desirable difficulty. The act of retrieving that fading memory is a more effortful and strenuous cognitive process than simply rereading it when it's fresh in your mind. This effort is the biological signal. It tells your brain, pay attention. This piece of information is different. It keeps showing up in the environment. It must be important. It is worth the energy to build a permanent home for it. The German poet Rainer Maria Rilke wrote of a different kind of growth. But the principle is the same. Be patient toward all that is unsolved in your heart and try to love the questions themselves. Live the questions now. Perhaps you will then gradually, without noticing it, live along some distant day into the answer. The spacing effect is the neurological equivalent of this profound philosophy. You introduce the information, you live the question. Then you patiently allow time for the forgetting to begin, and in that space, the deep, unconscious work of consolidation takes place. The act of returning to the material after a delay is like loving the question again. Each time you do this, the neural pathway associated with that memory becomes thicker, stronger, and more heavily myelinated, coated in a fatty sheet that makes the signal transmission faster, clearer, and more efficient. You are not just remembering, you are literally, physically, building the memory into the permanent architecture of your brain. Understanding the theory is one thing. Applying it with precision is another. For over a century since Ebbinghaus first plotted his famous forgetting curve, the central challenge has been to find the optimal spacing interval. If you review too soon, the retrieval isn't difficult enough to trigger significant strengthening. If you review too late, you've forgotten so much that you're essentially relearning the material from scratch, wasting your previous effort. While the perfect schedule can vary based on the complexity of the material and your own biology, extensive research has given us a powerful and immensely practical framework. I call it the 137 Revision Blueprint. This is not a rigid, unbreakable law, but a powerful starting point, an elegant and simple algorithm for consciously working with your brain's natural forgetting curve to install any new knowledge or skill for the long term. Step 1. The first encounter, Day 0. This is your initial learning session. This is where the grind has its place, but in a focused, limited dose. Whether you are learning a new piece of code, a set of vocabulary words for a new language, a historical timeline, or a complex scientific concept, this is your focused, deep dive session. Your goal here is not memorization, but comprehension. Use powerful techniques like the Feynman method to ensure you genuinely understand the material. Take notes, create mind maps, engage with the information as deeply and richly as possible. At the end of this session, the information is fresh, but it is also fragile, living in the temporary and crowded holding bay of your short-term memory in the hippocampus. The clock now starts ticking. Step 2. The first recall, Day 1. Approximately 24 hours after your first encounter, it is time for your first and most critical scheduled revision. The original Ebbinghaus forgetting curve shows that, without reinforcement, we can forget as much as 50 to 80% of new, novel information within the first 24 hours. This first recall session is the intervention that stops the catastrophic memory decay in its tracks. The key is that this session must be short and, above all, active. Do not simply reread your notes. That is a passive act of recognition that provides a weak signal to your brain. Instead, you must actively test yourself. Use flashcards. Try to explain the concept out loud from memory. Attempt to solve a problem without looking at the solution. The friction you feel, the mental struggle to pull that fading memory back from the brink of oblivion, is the precise stimulus your brain needs to flag the memory for consolidation. You have just told your brain, of all the things I learned yesterday, this one wasn't a random fact. This one is a priority. Step 3. The second recall, Day 3. After your first recall, you once again step away. You allow the forgetting process to begin anew, but this time you will find the curve is significantly shallower. You will retain more of the information for longer. Your next scheduled revision is approximately 3 days after that first recall. Again, this session should be active, brief, and focused on retrieval. You will notice that it is significantly easier to recall the information this time. The pathway is stronger, more established. This second successful retrieval sends another powerful signal to your brain. This information is proving to be consistently useful over time. Allocate more biological resources to making it a permanent fixture. You are now moving the memory from the intermediate storage phase into the early stages of the long-term archive in the neocortex. Step 4 of the third recall, Day 7. Your final scheduled recall in this initial blueprint happens about a week after your first encounter. By this point, the memory should be significantly more stable and require much less effort to access. This session serves to solidify it, to check its integrity, and to cement its place in your long-term memory. As before, this should be an active test of your recall. By successfully retrieving the information after a week-long gap, you have effectively proven to your brain's biological triage system that this is a piece of core, essential knowledge that needs to be kept readily accessible for the foreseeable future. You have successfully bent the forgetting curve into a line of retention. You have taken a fleeting piece of data, a transient pattern of neural firing, and have physically woven it into the permanent tapestry of your mind. The 137 revision blueprint is not just a study technique. It is a new rhythm for learning. It is a fundamental and profound shift from a mindset of brute force to a mindset of intelligent cultivation. It is the deep recognition that learning, like all forms of natural growth in the universe, requires a cadence of effort and rest, of attention and inattention, of planting the seed and then letting the soil do its silent, miraculous work. This principle extends far beyond the classroom and into every domain of human skill. For the musician, it means that 3 focused 20-minute practice sessions spaced throughout the day are vastly superior for skill consolidation than a single, exhausting 1-hour session that leads to burnout. For the athlete, it is the deep, embodied understanding that muscle is not built during the workout when fibers are being torn, but in the crucial periods of recovery and sleep that follow. For the creative professional, it is the wisdom of stepping away from a difficult problem, allowing the unconscious mind, what neuroscientists call the default mode network, to work on it in the background, often delivering the solution in a flash of insight when you are in the shower or on a walk. The great Japanese swordsman and philosopher Miyamoto Musashi wrote in his classic text, The Book of 5 Rings, "You can only fight the way you practice." This is a deep neurological truth. If you practice in a state of frantic, stressful, last-minute cramming, you will build a mind that is good at holding information for a short time under duress, but poor at deep, integrated, flexible thinking. If, however, you practice with the patient, intelligent, and calm rhythm of spaced repetition, you will build a mind that is calm, robust, and capable of retrieving knowledge effortlessly and elegantly when it truly matters. You are the gardener of your own neural landscape. The myth of the grind tells you to toil relentlessly, to exhaust yourself in the mistaken belief that effort alone is the measure of progress. But the fundamental laws of neuroscience offer a more elegant, a more efficient, and a more powerful path. Plant the seed of knowledge with focused, deep attention. Then, have the wisdom and the patience to walk away. Trust the deep, silent, and powerful processes of consolidation that happen in the spaces between. Return at strategic intervals to nurture the growth. This is how you bend time. This is how you cooperate with your own biology to master any skill, to learn any subject, and to build a mind that does not just store information, but embodies wisdom.